third thin film device, which I will be talking about today, is called HemoClear, and this evacuates blood from the lens surface by altering the hemoaffinity. So as I mentioned earlier, the medical application of this is basically to apply it to the lens surface of the endoscope, so that's where it would be applied. And so what causes fogging? So fogging is when 3D droplets of water accumulate on the lens surface, and because the light is refracted differently on the 3D drops of water, this leads to an opaque lens surface, and this is represented by the Vollmer-Weber growth mode. And actually what VitreOx does is it creates a polymeric nanomesh, which renders the surface of the lens hydrophilic, and it entraps the 3D water molecules and causes them to lie flatter. So the condensation pattern is a more 2D, and it lays flatter, so the lens surface is not as opaque. So this is different from other products that want to achieve anti-fog because they want to render the surface hydrophobic, whereas we want to make it hydrophilic, and the anti-fogging is represented by the Frank-Vandermeer growth mode. So what does fogging look like on the lens surface? Basically, just to get a perspective, this is an artificial eye. This outer circle here encapsulates the silicone membrane, and the smaller circle in the middle is the intra-ocular lens, which is placed on the eye. And so as you can see in the picture to the left, there's little 3D water droplets, and that's what a surgeon would see that would cause fogging. And then after the application of VitreOx, you would see a more clear lens. So the typical approach that is usually used to achieve blood evacuation is to use a common anticoagulant, heparin, which is found in many ORs and hospitals easily. However, in HemoClear, we use the agonist agent of heparin, which is called fibrinogen, as I mentioned earlier. So fibrinogen is the inactive blood protein that's found in our blood, and when it's activated, it converts the protein fibrin, which is present and used in the body cascade in our body when we need to form a blood clot. So this is a picture of fibrin. And so basically fibrinogen, when it's the inactive form, is we found through our research that it actually evacuates blood from the surface of the lens. So in this study, the main research objective was to find out how to apply HemoClear correctly to the lens surface to achieve optimal clear view conditions. And so we wanted to determine, we have VitreOx and we have fibrinogen, how do we layer them? Do we mix them and then apply it to the surface of the lens? Do we apply VitreOx and then fibrinogen, or vice versa? So this is a schematic of all the artificial eyes. So we used 8, and they were separated onto 2 separate water baths. And the water baths were heated to 37 to 42 degrees Celsius, which is about the temperature in a standard operating room in a hospital. And this was to achieve the fogging on all the lenses. And the blood we used to test the blood evacuation was canine blood. And so here you can just see what the fogging looks like on the lenses, and in this picture you can see what blood looks like when it's displayed on the lens. So this outer circle again is the silicone membrane, and this little puddle, the darker red, is blood. So as I mentioned, we had 8 different trials, but for the sake of time, I'll just talk about the first 3 eyes. So we had one artificial eye that just saw blood that was
coating that you would, if you're going to actually use it in surgery, apply before the device is ever shipped and sent out, and then they use it, or is it something that they need to apply like mid-surgery while if it starts fogging, apply it, or?
So right now, I think it would be used before surgery. If we know that the lens is going to fog, they could apply it beforehand to prevent that from happening. We haven't really talked about, I think, exactly when to apply it.
Well, this is a part of our development company. So we actually do have a VitreOx that you can apply during surgery in case of emergency if a lens occurs like in the eye. And that's one of the bit more iffy. You have to apply it correctly because you're going to need it and it will extract. But we have another coating that is a solid coating that we put on the surface of the endoscope prior to surgery. It can be at shipping or it can be in the surgical suite depending.
Right.
We have to overcome and sterilize. So the real compromise is to have actually the liver device, which Margarita is actually working on one of the students to just apply the coating by the surgical nurse just before starting the surgery. They do a prep on the table, and so just putting the lidocaine in the right amount is there for hours for the duration of surgery. And that's something that we only discovered by working with surgeons when you want the optimal moment to apply it, when it was the fail-proof, the fail-proof. That's a very good question. Because the whole development of this.
Well, we have a question. On one of your end slides, you said that VitreOx prevents occlusion by blood by changing the viscosity of it.
The hydro.
Can you go back?
Oh, this one?
Yeah, blood,
Yeah, so
viscosity of blood. So you gave a very nice sort of mechanistic explanation of how anti-fogging can work with a hydrophilic material. Can you tell us more about this? How does VitreOx alter the viscosity of blood?
So basically, they're both applied to the surface of the lens, and so the VitreOx is also a liquid essentially, and it would dilute the blood.
So just through that perspective.
Just through dilution, and that would make it less viscous, moving away from the surface.
But that's independent of the effect of the HemoClear. She just wants to make it clear that just as the VitreOx already improves the blood evacuation because it can make blood more viscous. But the mechanism of fibrinogen in the HemoClear, that's a little bit more complex.
Other questions?
Products like VitreOx seems like to help improve anti-fogging. Could be used for other applications. Have you guys considered anything else besides just the medical field? I know HemoClear has to do with blood. Yeah.
So it's definitely. I think we've had some contact with like an Olympic team for swimming, for goggles. Their goggles get fogged. Also with scuba equipment, they're concerned with that. So there's a lot of that.
Yeah, Saloni has focused entirely on the medical application because she's a pre-med student, but I have other physics students and engineers that are interested in the non-medical application, and the company as well has developed, like you mentioned, the goggles, but also in scientific instrumentation, when you have, for instance, certain type of probes to measure flow, for instance, in the sewer, you get foggy, and you use actually to measure the particle density. So there is actually a lot of application in instrumentation, in addition to the athletic. And I think the applications are all the ones that have closed goggles, like ski and so forth. But the most pressing, the one that has the most impact and most benefit, is the medical one because it can shorten surgery time by 50%, so cost. But also, you don't have to move as much, so you don't hurt the patients. The scarring is proportional to the amount of oxygen exposure. So those medical surgery is the future, but if you have to take the probe out, you increase the scarring the knee or the abdomen of the patient. And that is very critical. And then you also improve the risk of infection, what we want to. And finally, it can shorten the rehab time. And the estimate is to reduce rehab time from 6 weeks to 2 weeks by the reduction of